Assalamu alaikum. Chapter Direct and Inverse Proportion. Topic to be discussed are algebraic representation of direct proportion, graphical representation of direct proportion, and word prop. For reference, we are using exercise 1A of this book, so stay tuned.
Algebraic representation of direct proportion. From the previous example, we have found y upon x is equals to 15. That means the rate was constant. So let's call this constant, let's call this number 15 k. If we call this number as k, what will happen to this expression? If we represent constant by k, then y upon x is equals to k, or y is equals to kx. Therefore, if y is directly proportional to x, then y upon x is equals to k, or y is equals to kx, where k is a non-zero number and constant. If we substitute k is equals to 0, what will happen to our relationship y is equals to kx? So let's put 0 and then let's see what happens to the relationship. If y is equals to 0 x, and y becomes a 0, x will be y upon 0, which is impossible. So we can say if k is 0, then there will be no relationship between x and y. For the graphical representation of direct proportion, let's consider the example of overdue books. I have taken 4 initial values, and as we know that the rate in all the columns the rate remained constant, like 15 upon 1 is 15, 30 upon 2 is 15, 45 upon 3 is 15, and 60 upon 4 is 15. The question is, what is going to be the shape of the graph? So let's plot the graph and let's check out what is going to be the shape of the graph. So x against y, 1 and 15, 2 and 30, 3 and 45, and 4 and 60. So as we can see, that's a very rough graph. Yeah, as we can see, the shape of the graph is linear or a straight line. Another question that we have, that is it necessary that the graph needs to pass through the origin? Yes, it's necessary that graph needs to pass through the origin for 2 reasons. As we have discussed before, that in direct proportion, if one value increases, the other value increases. If x triples, y triples. If x decreases, y decreases. If x becomes 0, y will automatically become 0. One of the other reason is that since it's the straight line and we know the formula of the straight line, that is y is equals to mx plus b, right? So here m is the slope, x is the variable, plus b is the y intercept. That means with this formula our straight line is going to be like this. So this is y intercept. Direct proportion is basically the special case of straight line where b is 0. So if b is 0, our straight line will automatically fall on origin. Hence we can say If y is directly proportional to x, then the graph of y against x is a straight line that passes through origin. Here I would like to add few points. Number one, that if y is directly proportional to x, will x be directly proportional to y? Well, in this particular case, yes, but in general, no. Why yes here? Because we can see that we can see from the graph and from our data, as the value of x increasing, y value of y is increasing. X is directly proportional to y. But in general, it is not necessary. Why? Because we know our formula, y is equals to kx. Now, here x independent variable x is, whereas y is dependent variable. So that means the value of y depends on the value of x. So if the value of x increases, the value of y increases, but that case is not necessary for y. If the value of y increases, x may or may not increases. Let's consider this dependent and independent variable. Water level of river is directly proportional to rainfall. Here, rainfall is the independent variable x and the water level is the dependent variable y. Now, we can clearly see that water level of river depends on rainfall, but rainfall does not depends on the level of water. Therefore, we can say that y is directly proportional to x, but x may or may not be directly proportional to y. Practice question number 1, part 1. If y is directly proportional to x and y is equals to 10 when x is equals to 2, find an equation connecting x and y. So it is given in question that y is directly proportional to x. How this x and y variables are connected? Obviously, if y is directly proportional to x, then there must be some constant value connecting them. So we know the formula, that is y is equals to kx. The value of y was given 10 and x is 2. So we must put these two values into our formula to find out the constant, that is 5. We can put this constant into the formula to get the equation which is connecting x and y. We have to find the value of y when x is equals to 10. So from part 1 we know that k is equals to what? 5, and now the value of x is 10. So simple, we will put the value of x and we will find the value of y. 5 into 10. Will give us to find out the value of x when y is equals to 60, and we know the formula. Y is equals to 5x so y is equals to 5x x is equals to 60 upon 5, which means x is equals to, if y is directly proportional to x, then y is equals to 5, x is equals to 2. Find the value of y. We have to find the value of y when x is equals to 7. Very simple. We have to solve it through algebraic expression. And now we know, first we have to find out the value of k. Then we will put this value of k into the formula to get the answer. K is 5 upon 2. Putting the value. Y is equals to what? When k is equals to 5 upon 2 multiply by 7. Question number 3. If given that y is directly proportional to x, y is directly proportional to x, copy and complete the table. So here we have to find out on which column x and y, both of them are given, so that we can find the value of k, and then by after finding out the value of k constant, we can put it into our equation of direct proportion, algebraic expression of direct proportion. First, for k, which column I'm going to use? I think I am going to use yes, this column here. Y and x, both of them are given, so y is equals to kx. y is 30 kx. Now, and x is 5. Okay, for k, 30 upon 5, I am writing it down directly, is 6, since these are very simple questions. 6. Now I know the value of k, and putting the value of k into our formula, connecting x and y variable, 6x first case, and y is equals to 6, and when value of x is 4, y is equals to 24. So, y is equals to 24 when x is equals to 4. Okay, now 7 y is equals to 6x, y 6, and x value of x is 7. Now y is 6 multiplied by 7 is 42. So y is 42 when x is 7. Now I'm taking this question, when y is equals to 48. So now I have 48 x. I'm doing it directly, and I hope that everyone knows how to do this, how to solve this. X is equals to 48 divided by 6. X is equals to 8. So x is equals to 8. Then y is equals to 48. Get to the last part, that is y is equals to 57. Okay, y is equals to 57. We know the formula, y is equals to 6x I'm just converting into the mixed fraction to get the answer of the book. Question number 3, part 1. If x is directly proportional to y, so we will write the relationship. X is directly proportional to y. Always write the relationship of the variables like this to avoid further confusion. If x is directly proportional to y and x is equals to 4.5 and y is equals to 3, we have to find out an equation connecting x and y. So first we will find out the value of k. We know our formula of the direct proportion, that is y is equals to kx. Now from this formula I am going to find out the value of y, and then we will develop a relationship between x and y. K is equals to 3 upon 4.5. Further, we know K is equals to 3. 4.5 means I'm going to write it in the form of fraction. If x is directly proportional to y, find the value of x when y is equals to 6. So y is equal to 6, x is equals to what? And we have derived the equation from part 1. I'm going to use this. Right? X is equals to 1.5 multiplied by 6, which means x is equals to, it's better to write everything in the form of the fraction so that answer will be can be solved quickly. So we go to 1 are 2, 2 3s are 6, and 3 3s are 9. So x is 9. Similarly, part 3, find the value of y when x is equals to 12. From the above equation, I'm going to put the value directly. 12 is equals to 1.5 into y, okay, keeping y on one side, 12 divided by 1.5, again fraction to the rescue for quick answer. Y is equals to 8 is the answer. Question number 4, if Q is directly proportional to P, so I'm going to write Q is directly proportional to P, and Q is equals to 28 and P is equals to 4. Express Q in terms of P. From a question, Q is equals to K P. That means Q is going to be 28, K P is 4. Now, what would be the value of K? 28 divided by 4 will be 7. So, this is the value of K. Now, equation connecting Q and P is going to be Q is equals to 7 P, right, from this formula. This is part 1. Now part 2, find the value of Q when P is equals to 5. P is equals to 5. So, again from the formula, Q is equals to value of K is 7 and value of P from the data we have. Now 5 multiplied by 7, 35. value of P when Q is equals to 42. Again, very simple. From the formula that we already have, is it's going to be Q is equals to, the value of K is 7 and P is the unknown value that we have to find out. Now the value of Q is 42, and 42 divided by 7 will give us the value of P, that is 6. Question number 7. If Z is directly proportional to X, Z is directly proportional to X, and Z is equals to 12 and X is equals to 3. Find the value of X when Z is equals to 18. Now we know the formula. Z is directly proportional to X. Z is equals to Kx, where K is constant. Now let us put the known value and find out the value of K. So for K, (12 upon 3), that means K is equals to 4. Now we have to find out the value of X. So now we have two known values in our formula. We can easily find out the value of X. So Z is divided by 4. (9 upon 2). You can put it in the decimal as well, otherwise this is okay. Question number 8. If B is directly proportional to A and B is equals to 3, when A is equals to 18, find the value of B when A is equals to 24. So from the question I've got B is directly proportional to A and value of B is 3 when 18. So find out the value of B when A is equals to 24. When B is directly proportional to A, it's going to be a straight line whose one point is B is equals to 3 and A is equals to 18. And what would be the value of, at this point, when A is equals to 24, what should be the value of b, right? So from the straight line, I know I have the formula b is equals to KA. It's straight line, so on all the point of the straight line, k will be constant. For k, b upon a. Putting the values, now at what point in a straight line a is 24 and what will be the value of b at that point. So b is equals to Ka. Now b is the unknown value, but I know the value of k is 1 upon 6 and value of a is 24. 6 ones are 6. 6 fours are 24, so b is equals to 4.
Thank you for watching. Subscribe for more updates.